Hi there, folks. Today we're looking at quadratic functions in vertex form. And if you recall, when we're graphing a quadratic, it makes that U-shaped curve called a parabola. And the most important point on that parabola is the vertex. And so vertex form is nice because it basically gives us the vertex. So it's y equals a times x minus h squared plus k, where hk is the vertex. And a couple things to keep in mind here. One, we've already seen pretty much this same thing before. If you think back to absolute value functions and graphing those, absolute value functions were y equals a times the absolute value of x minus h plus k. And in this scenario, hk was the vertex as well, all right? And the reason this is the same thing is because of what we just talked about in terms of transformation, in terms of shifting this thing left, right, up, down. When you add or subtract from the x, it moves us left and right. When you add or subtract on the outside, it moves us up or down. That was true for absolute value functions, which is why hk is the vertex. But it's also true for quadratic functions, which is why hk is still the vertex, all right? These are similar forms because the things we've been talking about, those shifts up, down, left, right, they apply to all functions, okay? The big difference here is back when we did this with absolute value, we used the a value kind of like slope. Now we have to use the a value kind of like that pattern we've been talking about, okay? So I'm going to graph these kind of using that pattern we started to think about last time, all right? And so we'll kind of expand on that just a little bit, all right? But again, one of the other things that we have to keep in mind, and if you remember this from absolute value, is that h is an x minus h, which means it's x and then the opposite of h. Think of a minus sign as like an opposite sign here. So it's saying x and the opposite of the h value, the opposite of the x value for the vertex, okay? It's plus k, so that is the y value for the vertex, all right? For example, if I look at this guy, see it's in that format, and right here, this is the opposite of the x value, which means the x value for the vertex is positive 1, all right? And then over here, plus k, that is the k value, so that's a positive 2. And the same thing happened when we looked at absolute value. We had to do the opposite of the thing with x, but we took the other guy just the way it was. So that's my vertex, all right? And the axis of symmetry, we already know, is always x equals the x value from the vertex. So it's x equals 1. It's the line that goes right down through the vertex. And now really, that's enough information to graph this thing, okay? So if you kind of think about this, so let's plot that. Let's see, 1, 2 is right here. Axis of symmetry, I'll draw it kind of as a dotted line. You don't necessarily have to draw the axis of symmetry, but it makes it easier to graph this thing a little bit faster. But then look at the a value right here. The a value is what's out front. In this case, it's a 1. 1 is like my standard shape for this thing, all right? And we started to talk about that a little bit last time, but now we're going to use that to graph. See, if you remember, the very first parabola we graphed was y equals x squared. And the pattern from the vertex was over 1, up 1, over 2, up 4, over 3, up 9, over 4, up 16. The pattern is squaring how far over you go, all right? So instead of like slope where it's over this many, up this many, over this many, up this many, it's over this many and then up the squared amount, okay? That's kind of the standard shape. Any other parabola that also has an a value 1, because keep in mind, that's an a value of 1, any other parabola that has an a value 1 is going to follow the same pattern. So right here from the vertex, if I go over 1, I go up 1. And then start over. From the vertex, if I go over 2, I go up 4. That's the standard shape of this thing. If I go over 3, up 9. Okay? And then using the axis of symmetry, I can reflect those points. If they're looking in a mirror, where's the reflection? This is the graph that I'm looking for. Okay? If you're looking at that going, oh man, that's pretty tough to kind of figure out that pattern, that's okay. You're going to go to your XY chart like we were doing the other day. And if you go to the XY chart, that's fine, but you need to practice plugging this in. Start with the vertex in the middle, and then count up and down from there. So if I'm counting down 0, -1, if I'm counting up 2, 3, and I'll plug those values in, and you'll be able to convert that into a graph, okay? So those are your options. Either find the vertex and then use the a value, or find the vertex and then use an XY chart, okay? Again, try to use the a value because, man, that's going to be huge. If you can do the a value, you're in really, really, really good shape, all right? So if I look at this one, again, vertex form, it's the opposite of this guy, so that's a -2 for my vertex. And then here's the k value is a +4. Axis of symmetry is always x equals the x value from the vertex. It's a vertical line that kind of goes right down through the middle of this thing. And now I can start plotting this. Ready? -2, 4. I could plot the axis of symmetry here as a dotted line. Oh, I think I used green last time, so I should probably use green this time, right? Keeping ourselves consistent. Again, if you do graph the axis of symmetry, it has to be a dotted line, all right? And then from here, you could go to your XY chart if you want. I'm going to look at the A value. Look at the A value here. It's a -1. So -1, the 1 indicates the same shape, but the negative tells me it opens down. So again, think about that pattern. From the vertex, over 1, up 1, over 2, up 4, over 3, up 9, over 4, up 16. Instead of going up, you're just going to go down. So it's -1. So it's going down in each of those values. So from the vertex, let's count. Over 1, down 1. From the vertex, over 2, down 4. From the vertex, over 3, down 9. And I can reflect those using the axis of symmetry. See, I don't even need to count. I could count. It's the same pattern on the other side, but that's enough information to graph this thing. Notice it's the same shape as a lot of the parabolas I've been graphing, all right, because the A value is still a version of 1. Okay, and the value of A in terms of positive or negative doesn't matter except for opening up or down. The value behind that sign tells us the shape. So if the value behind the sign is a 1, it's the standard shape, that standard pattern. Okay. Let's jump to the next one. If I look at this guy, again, vertex. This is in vertex form. So here's the opposite of the x value. It's a -1. Here's the y value hanging out. That's a -3. Whoops. Got it. It's got to be blue. The other one was blue. Axis symmetry is x equals the x value from the vertex. And so now I plot this thing. Ready? -1, -3 is right here. Axis of symmetry I can plot as a dotted line. And again, you don't necessarily have to have the axis of symmetry. You could just imagine it. But now look at the A value this time. The A value this time is a 2. All right? So here's how that affects things. The original pattern was over 1, up 1. Over 2, up 4. Over 3, up 9. Over 4, up 16. All right? If I slap a 2 out front, it's basically going to multiply all the heights by 2, which is that second column. So instead of up 1, it's going to be up 2. Instead of up 4, it's going to be up 8. Instead of up 9, it's going to be up 18. Instead of up 16, it's going to be up 32. Notice all I did was multiply all those values by 2 because the A value is a 2. If that A value is a 3, I would multiply all those values by 3. But that's now my new shape. That's my new pattern. And so from the vertex, again, we're counting from the vertex. From the vertex, it's over 1, up 2. From the vertex, it's over 2, up 8. From the vertex, it would be over 3, up 18, which is kind of off my graph. But now I can reflect these using my axis of symmetry. And so what happens is I get a parabola that's just kind of skinnier than the other parabolas, okay? The thing's being stretched vertically, all right? And so if I stretch something vertically, it gets taller, it will look skinnier, okay? But that's it. We just changed the pattern by multiplying it by the A value, okay? If I look at this one, same kind of thing. Here's the x, or the opposite of x. So the opposite of that would be a -2. Here's the y. Notice it's a +4. Axis of symmetry is always x equals the x value from the vertex. And now from here, you could do an xy chart if you want, all right, if you're not feeling this A value thing. But now the A value really looks like this. Ready? Original pattern over, actually, let me graph this thing first. Sorry, let me plot these points. That's what I've been doing. It's -2, 1, 2, 3, 4. And the axis of symmetry, our good buddy. And so now think about the original pattern. The original pattern was over 1, up 1. Over 2, up 4. Over 3, up 9. And the original pattern should be easy to remember because it's squaring those values, okay? So now, the fact that the A value is a -1/2 means this thing is going to open down, and I'm going to do half the distance this time. So instead of a 1, it's going to go down 1/2. Instead of a 4, it's going to go down 2. Instead of a 9, let's use a decimal here, -4.5. Instead of 16, it's going to go down 8. See, I'm just multiplying all those values by 1/2, and so now this is my new pattern. Over 1 down 1/2, over 2 down 2, over 3 down 4.5, over 4 down 8. And I could keep going with that, but now I can reflect those. And see, as you get really good at these, you don't have to write that pattern down anymore. Like when I do this, I don't write down all that stuff that I wrote down off to the side. I just do it in my head. I said, okay, instead of down 1, I go down 1/2. Instead of down 4, I go down 2. Okay? But again, just write that little pattern off to the side, and it's faster than doing an XY chart, but it yields the same result without the work of having to plug this thing in. Okay? So memorize that original pattern, which should be easy. It's just squaring things. Whatever the A value is, multiply that second column of the pattern by that thing. That will tell you where to count from the vertex, okay? And then we get really accurate graphs very quickly. If I look at something like this guy, it says identify the vertex and the axis of symmetry, and then see if we can write the equation for this thing. So like this one, here's the vertex. It's right here. So the vertex looks like the ordered pair 0, 3. And the axis of symmetry would then have to be x equals 0, because x equals the x value from the vertex. We can kind of imagine it there. It's a dotted line that goes right down through the middle of this thing. But now let's think about the equation of this guy, all right? The equation, really, I need to identify what the A value is. And so we got to start thinking about this A value for a second. The first thing you should know right away about the A value is look at the parabola. The parabola opens down, so we know the A value has to be negative. And then look at the pattern. See, the standard shape would be over 1 down 1, over 2 down 4, over 3 down 9. So here's what the standard parabola would look like. So notice it looks wider than the standard parabola, but this first one's hard to tell. Over 1 down, I don't know, it looks like maybe like a 1/2 or a 1/4 or something like that. So maybe go to the next one. It's over 2 down 4. And so again, think about it. The original pattern was this. It was over 1, up 1 or down 1 or whatever it happens to be in terms of the direction. 2 was 4, 3 was 9, 4 was 16. But in this parabola, this guy, instead of down 4, it's down 1. So think about what would you have to multiply that 4 by to get a 1? The answer is a 1/4. See, this is a wider looking parabola. It's been shrunk vertically. And just like the 1/2 we just did, we got a wider parabola when I had a fraction there. And so for this one, the equation, kind of investigating that pattern, would be a negative 1/4. And then x minus 0 squared plus 3. That's the equation, this thing in vertex form. And yeah, you could simplify this and kind of drop the minus 0 and just say x squared plus 3. That would be fine also, okay? If I look at the next one, same kind of thing. Think about the vertex here. So the vertex on this one is 1, negative 1. The axis of symmetry would have to go right down through the middle of this thing, so x equals a 1. And we can see it here, cutting right down through. And then think about the pattern here. Look at the A value by thinking about the pattern. In this particular example, if I count from the vertex, it's over 1, up 1. And then over 2, it looks like up 4. And that should ring a bell because that's my standard shape. And the standard shape opening up, this thing's going to be a 1. So y equals 1x minus h squared plus k. Okay, and notice this is the opposite of h. This is the exact k value, all right? And if you want to write the one out front here, that's fine also, okay? But again, it's just a matter of the kind of the point of these questions is to kind of start thinking about that A value. Think about how the A value affects that pattern, affects the shape of this thing. Because if you can graph it using the A value, life becomes a lot easier for you. Okay, so vertex form, it gives us the opposite of the x value, and then it gives us the y value for the vertex. We can then use the A value to graph if we modify the shape, modify the pattern, or do an XY chart. Okay?